Okay, applied calculators, in this screencast, we're going to look at a few initial value problems. They are opportunities for us to practice anti-derivatizing, which is not really a word, anti-differentiating. And we'll do that both in a theoretical context and in a practical context. We begin with a theoretical context. Suppose that f prime of x is 8x cubed plus 10x, and f of 2 is 6. Find f of x. So what is an initial value problem? An initial value problem has a derivative and some initial condition. One point that we know is on the curve. And then it asks us what the function is. So we know the derivative, we know one point on the curve, we're supposed to find what the function is. How can we do that? Well, we know a little bit about the function. The function has to be an antiderivative of this thing, which means that when we take the derivative of f, we end up here. Well, the power rule comes into play. The antiderivative of x to the third is x to the fourth divided by 4, but there's already an 8 there, so that's a 2. The antiderivative of x to the first is x to the second divided by 2, but there's already a 10 there, so that's a 5. And then it's a family of functions. There's some constant that we don't know yet. Well, how could we find that constant? Well, we know this piece of information. We know that f of 2, well, f of 2 is 2 times 2 to the fourth. That's 16 times 2, 32. 2 squared is 4 times 5 is 20, plus a constant. We know that this is 6, which means that the constant is 6 minus 52 is negative 46. So now we know what the specific constant is that makes the function go through this point. So we know exactly what f of x is. That's 2x to the fourth plus 5x squared minus 46. There's only one function in the whole wide world that has this derivative and passes through that point. Question 2. Why would we ever want to do this? Let's suppose that the marginal revenue function for a particular object in a particular factory is given by r prime of x is 200 e to the negative 0.2x plus 6. If you sell 0 items, you make $0. Find the revenue function. What's the revenue function? Well, marginal revenue is the derivative of revenue, right? So this is the derivative of revenue. So revenue is whatever function is going to have a derivative of this thing. Well, this piece is the easy piece. And there's a plus c going to go at the end. This is the tricky part. What do we remember? We remember that the derivative of e to the thing is e to the thing. So I'm thinking that there has to be some version of this happening here. But when we take the derivative of e to the thing, we get e to the thing times the derivative of that thing, which means that this negative 0.2 gets multiplied by something and ends up looking like this. So what's that gonna be? Well, it's got to get multiplied by like negative 1,000, doesn't it? It's got to be negative 1,000. It's got to be. because the negative 0.2 multiplies by that gives you a positive 200. And so this becomes the revenue function once we know what C is. Well, if you sell 0 items, you make $0. If you sell 0 items, well, e to the 0, that's 1 times negative 1,000. That's 0, right? If you sell 0 items, you make $0, which means that the constant is 1,000, and now we know that r of x is negative 1,000 e to the negative 0.2x plus 6x plus 1,000. I'll do one more. Let's suppose that the velocity of an object is 3t squared minus 8t. At time equals 0, the position is 12. Find the position function. This is the position function. And we know that velocity is the derivative of position. We know that this is the derivative of the x function. So how do we find the x function? Well, we use the power rule because this is a polynomial. So the thing whose derivative is 3t squared is t cubed. The thing whose derivative is 8t is 4t squared. There's a plus a constant hanging out here. Take a moment. Use this piece of information. Tells you what c is, doesn't it? And so the position function is t cubed minus 4t squared plus 12. Every initial value problem goes the same way. There's a derivative, there's a specific point on the curve. The specific point on the curve helps us find out what c is, and then we answer the question. Those are 3 examples. We could do a dozen more, but there are suggestions at the bottom of the watch page that'll do better than if we did 8 more together. I'll see you when we gather.